Hi everyone, our final video today is going to be all about looking at special products. So for our first example, we're going to look at difference of squares. So here is an example of one. So we have 8x squared minus 18y squared. So I want to think back to that very first rule we talked about, which is make sure that you are trying to find the greatest common factor to begin with. It'll make everything way easier if you remove that common factor prior to actually trying to factor it using any of the methods we've talked about so far. So for this one, you can probably see that there's a common factor of 2. So let's start there. So if we factor out 2, we get 4x squared minus 9y squared. So then when I'm looking at my term that's left over in here, I see that 4x squared is a perfect square. 9y squared is a perfect square, and we are subtracting them. So that means it is a difference of squares. It's not super easy to print on here, so that says difference of squares. So what do we do with that? Well, the pattern, if you look back in your notes, is that we end up with the square root of the first term, so 2x, minus the square root of the second term, so 3y, times 2x, plus 3y. So they have to have these two different signs so that the middle term is removed, so that it's only a binomial. Okay, so that's an example of difference of squares. I'm going to skip to the next page, so you won't be able to see this anymore. So take a good look, write down anything you want, rewind, listen to the sound of my lovely voice again. Okay, and now I'm going to add, and we're going to take a look at a different special product, which is a perfect square trinomial. So this is a different pattern, so notice that it's a trinomial. So 4x squared minus 12x plus 9 is the example we're going to look at. So this is a perfect square trinomial. And how can we tell it's a perfect square trinomial? Well, the pattern is that if you have a plus or minus b, all squared, you should get, when you expand it, a squared plus or minus 2ab plus b squared. So we have to check to see if it's a perfect square trinomial. Let's double check here. Our first term is a perfect square. Is it? Yes. 4x squared is a perfect square. Our second term, or our last term, sorry, is a perfect square. Well, yes, it is. Our middle term is 2 times the first times the second. Well, let's double check that. Let's rewrite this a little differently. Now, you might not have to do this to see this pattern, and eventually you won't have to, but what I'm going to start with here to give you a way to sort of check is that if you write the first term in a different manner, right? Still the same thing, 4x squared, 2x all squared. And then 9, so 9 I'm going to write 3 squared. And the middle term has to be minus 2 times the first, so 2x times the last one, times 3. And is that the case? Well, I think so. 2 times, or negative 2 times 2x times 3 is going to give me 12x. So it is a perfect square triangle. So that means the pattern for factoring it is, it will be a, which is in this case, a, which in this case is 2x, so 2x, and then b, which in this case is 3. So then I put 3. Now I need to decide what sign to put in the middle, and it's all going to depend on the middle sign in here. So if it's negative in the middle, then I need a negative in there. And then that is all squared. Now, of course, you can use guess and check, or you could use decomposition to factor this if you don't happen to notice that it's a perfect square trinomial. But if you do notice, it'll save you a bit of time to see that pattern. Okay, great. Make sure you do lots of practice because it will become more intuitive with lots of practice. Thanks. And come and see me if you have any questions.